Okay, this is a continuation of section 8.2. We had done numbers 1 through 9 in the last video, so beginning with number 10. Okay, so this particular problem gives you the values for side A, side B, and angle A. So let's go ahead and just draw any kind of triangle, but making sure to put these values in the proper place. I'm going to label this A, B, and C. That would make this side A, that would make this side C, and that would make this side B. They've given us A is equal to 1, B is equal to 7, and angle A is equal to 70 degrees. We have a complete pair for A, a partial pair for B, and so we're going to jump into law of sines. Now, notice that you have been given, again, side, side, and a non-included angle. This is the ambiguous case. So when you begin before you actually begin solving for anything, you don't know if it's going to turn out to be one solution. In other words, a triangle can only be drawn one and only one way, or whether the triangle splits into two separate triangles, as we have seen in previous problems, or whether there's actually no solution at all. In other words, even though you've drawn it, you really haven't given yourself a chance yet to see whether or not this really can even come together at the corners to form a triangle, but we're about to figure that out. So be aware of that every time you're given a side, and a non-included angle. Remember, this is a non-included angle. This would be called an included angle, an angle that's in between the sides. So when you're given side, non-included angle, ambiguous. Okay, so I'm going to go with my pair right here. I know I am looking for an angle because the other pair that I've been given in partial is this B. I'm looking for an angle, so I'm going to put angles at the top. So it's going to be sine of my unknown angle. The denominator would be the side across from that, which is 7. I'll set up one more fraction in the same manner with angles at the top and sides at the bottom. So A is 1, and then I'll do the sine of 70 degrees at the top. Okay. Isolating for angle B would mean that you'd have to cross multiply this 7 right across the equal sign, which would place it right up here. Therefore, it is no longer there. Continuing with this problem, it would now look like this. Sine of angle B. Then we're going to go into our calculator and put all of this. Sine of 70 times 7. You need not put the 1 in there. Make sure your calculator is in degrees. Just check that real quick. Mine is. And it is sine of 70 times 7. So that is 6.5778. When you're in the middle of the problem, you should always hang on to at least 4 numbers after the decimal so that your answer is as accurate as possible in the end, even though you're going to be holding the same number. But anyway, we're going after an angle, and anytime you're going after an angle, that involves inverses. So it's inverse. You go from a non-inverse statement, which is an inverse statement, just simply by switching these two. That's from chapter 7. Okay, so you have 6.5778 would be equal to angle B. And I don't know if you remember this, but when we were learning inverses in chapter 7, this has to be between -1 and 1, so maybe you can understand why when you put it in the calculator, look what happens. You go second inverse, you dump the number in there, the 6.5778, and see how it quits on you, and that's because the domain for an inverse function has to be between -1 and 1. That's why your calculator would not. It's telling you by saying quit that it is undefined. That means that when it is an undefined situation, when trying to calculate a value, that means that the triangle does not exist You really can't even draw it. It wouldn't come together at the corners or at the angles. So that is choice C. Moving now into the application problems. And I'll do as much as I can here, depending on how many steps there are. But many, many of these application problems are generally more than one step. If they're the easiest level, then possibly you will only have to set up one step, but let's just see how this goes. Okay, so let's read this. You usually have to read these problems a few times and try to figure out where to put everything. But every time you get a piece of information in the problem, transfer it over here, and then try to use the pieces of information they've given you to find any other things that you can possibly find that are real easy before going into the law of sines, if that's possible. So to find the length of the span of a proposed ski lift from A to B, proposed ski lift from A to B, that's that piece right there. A surveyor measures an angle called DAB. That means you go to D, then to A, then you turn to go up and travel to B. That's that angle right in there, DAB, 25 degrees. They've labeled it for you. And then walks off a distance of L equal to, and they've already labeled the L, that's this part of the triangle, one side of this triangle, at 1,550 feet. So let's go ahead and put that in there. Okay. And measures an angle. So let's see. If you're going from A, that's A right there, to C to B, that angle is 15. They've also put that in there for you, and they ask you, what is the distance from A to B? So you are looking for this right here, all the distance from A to B. So let's see. Working inside the one triangle that we do have right here, we notice that 15 is across from X if I want to, use that in my law of sines. And then I'm going to need the angle that's across from this side that I actually have been given. And that angle that's across from the 1,550 feet, that would be angle B up here, but I don't have that. However, what they've given you here does allow you to find that angle right there, because anytime there are two angles, these are called adjacent angles. Two angles that live right next door to each other. There's a line that separates them. Those two angles, as you can see, add up to half of a circle, which is 180 degrees. So if you wanted to find angle BAC, as it's called, I'll do that first. That will be your very first step. It's just simple subtraction. These two angles add up to 180. You already know one of them, so subtract the one you do know to get the one that you don't know. So this would be 155. And you can put that in there. You can try and squeeze it in there, but that is 155 degrees. Now, what this allows you to do is, now that you know two of the angles inside this skinny little triangle right here, you have a 15, you have a 155 right here, and we needed this angle so that we can continue working with law of sines. Okay, so step 2 would be to find the third and missing angle inside the triangle so you can continue with law of sines. Also, inside a triangle, the angles add up to 180. Not only do two angles side by side add up to 180, but the angles inside of a triangle add up to 180. So if we're going to find angle B, which is up at the top, we'll go 180. That's what we start off with. And then take off the two angles that you do know. You can add them together first and then subtract one time, or you can just subtract them off one at a time. So let's subtract off that 155. Let's also subtract off that 15-degree angle, and we will get angle B at the top. So that's going to be 180 minus the 55 minus also the 15-degree angle that they gave us. And that gives us 10 degrees for this angle. I'll put it right in here because there's not much room to write a number there. that angle right there is 10 degrees. So now we can finally finish this problem with what the main emphasis of this section is, which is law of sines. Okay, we have angle of 10 degrees across from, it's the side that's opposite to this 10 degree angle is the 1,550. So that is a complete pair. Then the pair that we want to use to find the unknown would be the 15 degrees. We'll do the sine of 15 degrees and the side that's across from it, which is the x, which happens to be the question in this problem. What is the length of the ski lift from A to B? Okay, so here we go, setting up our fractions. It is a side that we're looking for. Therefore, when we set up these fractions that are created through the law of sines, we'll put sides at the top. Always put your unknown at the top so that you're not creating an extra step. So x is opposite to this 15 degree angle. We're taking the sine of 15 degrees. Then we're going to set up one other fraction, and we'll use the complete pair, the pair where we have 10 degrees that we found through steps 1 and 2. And then the side that's across from it, which is the 1,550. Okay, cross multiplying in order to isolate the variable up here at the top would allow us to swing sine of 15 right up here into the numerator. So now this is not here anymore. It's up here in the numerator because we've crossed multiply. So it's 1,550 times sine of 15 divided by sine of 10. So we'll put all of that into our calculator, and then we will have the length of the ski lift. Okay, so let's go 1,550 times sine of 15, and then our divisor is divided by sine of 10 degrees, and that gives us 2,310, and then just look to see what they ask you to round the final answer to. And you can see that they're telling you not to round the final answer, not to this extent anyway. Just hold on to more than 2 decimals as you're working the problem, preferably 4 to 5 numbers after the decimal. But if you're leaving everything in your calculator window, you're even going to be more accurate than that as you go along. So now rounding to 2 decimal places would be 2,310.24. And you have all these answers on the last page or two of this outline so you can check as you go along. Okay, now moving on to number 12. So that was 3 steps. Some of these are more than that, some of these are less than that as with regard to steps. Okay, number 12. An aircraft at Z, here it is up here, is spotted by 2 observers. One is standing at X, one is standing at a location called Y. As the airplane passes over the line that joins them, as it passes over this line right here, each observer takes a sighting of the angle of elevation. That means here is the observer. They had to look up in order to look at the plane. That's why it's called an angle of elevation to the plane, as indicated in the figure. Those angles of elevation are A, 20 degrees, and also B is 20 degrees. This, in other words, this observer located at X had to look up 20 degrees to see the plane, and from where this person was, they also had to look up 20 degrees. Okay, angle of elevation is always measured between the line of sight to the object and the horizontal. Same thing over here. Okay, so how high is the airplane? That means they are looking for H. They want this altitude. How far off of the ground, from the ground up until the plane. You always measure that when they ask you how high something is as a perpendicular distance. So the first thing that we're going to do in this problem is we're going to find, this one angle that's up here. And by the way, if you don't remember this, this is an isosceles triangle. Isosceles triangles, just in case you've forgotten some of your geometry theorems, Isosceles triangles have base angles that are congruent, and then the sides that are opposite those base angles are also congruent, whatever they happen to be. If this one's 5, this one's 5. So the sides opposite the base angles, I'm not going to write all that out, they are also congruent. So you can kind of mark that both of these are congruent, because if you find one, you're actually finding both of them. And, those numbers are probably going to help us find the height. But let's continue. Okay, so I think the most obvious thing as you try to fill in anything that's missing and anything that's going to help you, let's also put in that this is given in the problem, this length from here to here, as 1,550. That was one of the given pieces of information right up here. Okay, so now we can look at everything that we have. I think the first thing that I'm going to find is angle XZY, and that would be right here, XZY. That is this angle right up here at the top. I can use law of sines as I do that. So I can go this angle, which I'm looking for. Actually, that angle we already have, don't we? Because if we have 20 and 20 is 40, and this angle, this triangle right here has a sum of 180 degrees, you could just go 180 minus the 40 degrees that's been used up on those other two angles called angle A and angle B. So we really don't have to use law of sines for that because it's much easier than that. Okay, so we have this being 140. Then the next thing that we can try and do, notice that, let's call this something. We can call this R. This will be the same length. The reason that I am now trying to find this side is because in the end of this problem, I know that I'm trying to look for H. I'm just trying to rationalize with you why I'm taking these steps. I found this first. I thought that might help me as I go and do the next step. And now I'm trying to find things that either belong to this right triangle or this one. This is just a replica of that. So if you're looking for this side right here, remember this is a right angle, you could be looking at the entire big triangle that it is part of, and you can find that, because the minute that you find this, you can use SOHCAHTOA on this little tiny right triangle. So I'm kind of in my thinking strategy working backwards. I would like another piece of this little right triangle, so first I'm going to use law of sines in order to find that. Okay, so I could go, this 1550 right here is across from 140 in the big triangle, which is why I found the 140 first. I knew I wanted to use anything that they had given to me, and this was across from an angle that I didn't know yet. So that's why I quickly in step 1 subtracted the 40 in base angles that they gave me to give me a 140 up here. Now I have a complete pair as I use the law of sines. Now when I go and find R, notice that that is a side, so I'm going to keep my sides at the top. 1,550 is a side. It is across from an angle that measures 140 degrees. And then I want something that incorporates R now. So continue thinking about this big triangle, not these little baby right triangles, and let's find another pair. That other pair is going to be this side that I'm looking for, and you can either look for this one or this one, it doesn't matter. The side I'm looking for, and that is across from an angle that measures 20. So I'm going to go sine of 20 and R right here. Then again, as we've done in every problem, we isolate the variable that we're solving for just by cross multiplying. So we're going to swing that sine of 20 up there. Let me finish that here. I'll just rewrite it here since it's getting a little messy. So we're going to swing the numerator. That means we're cross multiplying. That'll be right next to a 1,550, which is already in the numerator. and a divisor of sine of 140 degrees. That'll leave the r all by itself because we have swung it up into the numerator here, so it's no longer there and r is by itself. At that point, get in your calculator. So it's sine of 20 times 1,550 divided by sine of 140. That gives us 824.7377. Okay, so just a recap of what we've done so far. I wanted to use this 1,550 because when we started this problem, it was the only side I had. Well, if you're in a section where you're doing law of sines, you're working on an entire triangle that is not a right triangle. And I was looking at this one called XYZ. And you want to use a side, you need the angle across from it. But I didn't have that. So knowing that I didn't have that and that I wanted to use this side, I quickly went 180 minus 40 to get that 140. That accounted for step 1. Then by the time I got to step 2, I was already thinking more along the lines of what is the final answer that they want me to get? They want me to get this right here. How high is it above the ground? And I noticed that that height is part of a little right triangle that points to the right over here. It's also part of a right triangle that points to the left. So I decided if I was going to use SOHCAHTOA, which is something that we commonly used in chapters 6 and 7, that I needed at least one of the sides of the right triangle. Can't use SOHCAHTOA or any of those definitions where you're using x over y, y over r, unless you have one side. And you certainly can't use Pythagorean theorem because that requires two sides. So since I knew I needed one side, what I decided to do is use law of sines in the big triangle in order to get that. Across from 20, and also I did 140 across from 150. So now that accounted for step 2. And then finally now I'm going to switch over. Now you're going to see that this is a very common thing where you will be using either law of sines or law of cosines. You haven't gotten to that yet. It's in the next section in a big triangle that has no right angle in it, which is why we learned these theorems, law of sines, law of cosines in the next section, things that are adequate for triangles that are not right triangles. And then you'll find yourself switching over to all the theorems you learned about right triangles in chapters 6 and 7. You're merging everything that you've learned. So now finally, let's go to step 3. I am now ready to find that height that comes down the middle. So now what I want to do is figure out, okay, what am I going to use? Where am I going to stand? If I want to find this, which is called H, I'll just put that H there again because it's kind of covered up. If I was standing here and I want H to be in the problem, that's called opposite. Everything has a name with respect to where you're standing. I'm standing right here on the 20-degree angle. So H would be considered opposite, but I also want to have the R value that I just found in the problem. I now know that this 824.7377 is a value that I just found by using law of sines. So I'm going to be using opposite and I'm going to be using hypotenuse. So what you have to be thinking is which of the 3 formulas in SOHCAHTOA uses those things. Opposite and hypotenuse would be sine. So it'll be the sine of where you're standing. That definition is opposite. I'll just put O. Remember, the second and the third letter form the fraction. They are how the fraction is defined. Okay, so this is going to be, my opposite is called H. My hypotenuse is my 824.7377. And let's go ahead and get a decimal for this. And that's sine of 20 and that is 0 is equal to, let's grab these things that are specific to the actual picture, h over 824.7377. Notice that you only have one variable that is unknown here, so all you're going to do to isolate it is cross multiply. This 824.7377 is going to jump right up here into the numerator and will no longer be in the denominator. So h, in the grand finale of things, this says that we should round to 2 decimal places, is, I already have the 0.3420 in my calculator, times 824.7377, and you get 282.08. Okay, if you round it to 2 decimal places, that means go 2 numbers beyond the decimal and decide whether you should keep that number in the second decimal place the same or round it up. 282.08. It rounds up. Okay, so that is that answer right there. Okay, moving on. We have numbers 13 and 14 still left to go. Okay, let's see how many steps this one is. It says a famous leaning tower, Pisa, was originally 180 feet high, so that was the length of this. It says at a distance of 121 feet from the base of the tower. And you can see from, you might not be able to see this too clearly, but they drew this line in solid blue. That means this 121 is from right here, dead center, at the base of the tower, all the way out to angle Q. That measures 121. So in this triangle that they've drawn for you here, one that comes right down the tower, this one that goes to Q, and then this 121 that's measured from Q into the dead center of the base. So we have angles R, we have angle Q, we have angle P. Okay, so now let's see. It says, after that, an angle of elevation to the top of the tower. That means there's someone standing here on the ground and they have to look up. They have to elevate their line of sight in order to see the top. And that is why this is called an angle of elevation. Okay, so it is 60 degrees. They've already put that there. Find angle RPQ. Find angle RPQ, also known as just P. Okay, so let's see. What we have here, if we jump into making decisions as to whether we're going to use lost signs or we're going to start it off with subtraction, the best thing here would be to find angle, let's see, we have a complete pair right here, we have a Q pair, and do you see how they're leading you into R? You have a semi-pair there. So always when you have a semi-pair, you start there. You're going to finish that pair. This is an angle. We're going to keep angles at the top. So it'll be for step 1, we're going to go sine of angle R. And what's across from it is the 121. And then we need another fraction. That would be this complete pair, the 60 and the 180.5. Keeping angles at the top just like I did here. So sine of 60 at the top, and then the side across from that comes measured in at 180.5 feet. We want to isolate this unknown, the R, the angle R, and so we're going to swing the 121 up here into the numerator. Therefore, it's no longer there. We'll put that in our calculator. Okay, so we have sine of 60 times 121, oops, sine of 60, close that up, times 121, it's 104, divided by 180.5. And that gives us 0.5805, even though we're going to hold on to more of that. So right now we know that the sine of angle R is equal to 0.5805 approximately. Try to remember that from chapter 7, which was mostly about inverses, that you need to write this as an inverse statement in order to find angles. And you are looking for an angle. You just switch the angle and the decimal. So coming right up here, this is now going to read inverse of 0.5805 is equal to angle R. You don't have to put that little angle symbol. Just having a capital letter means you're finding an angle. So now we're going to put this in. We're already in degrees. That means our inverse is going to come out in degrees. So second sine 0.5805. And I got 30, it says for, let's see, we're rounding things pretty much to 1 decimal place. Round all intermediate values to 4 decimal places. So as I was suggesting, I'm always suggesting to you that unless you're at the very last step of the problem, you should be holding at least 4 decimal places. So 35.4857. Angle R is, now this is not an answer that they asked us for, but it's necessary to get to the other parts of the answer, the parts that they are asking us for. So right now we have 35 degrees, 0.485, 35.4857 degrees for angle R. And you can, put that in there. You're not going to be able to squeeze it in there, but let's put it right here. Okay. Then, now this actually is one of the answers that they've asked us to find. So we worked with what we have. You want to work with the complete sets that you have, being that you've just learned law of sines. And I was prompted to find angle R first because it would have completed this R pair right here. I knew I was going to use that, and I was prompted to use that, even though it wasn't one of the questions. But now I can answer this right here. So step 2 is going to be where I can find angle RPQ. The letter right in the middle, if you have forgotten this from geometry, is where the actual angle is. So RPQ, also known as just angle P. So if I want the 2 angles that you already have, one was given, that was the 60, and then there's the one that I found, which made it possible to finally find RPQ. So take off 35.4857 degrees, and then we'll round that off to 1 decimal place. Okay, so that's 180 minus 60 minus the 35.4857, and we have 84.5 for 1 decimal place that they've asked us to do. So 84.5. Okay, so that's one of the answers. Then this last question says, find the perpendicular distance from R down to this segment right here called PQ. How straight I can draw this. We're trying to go from R to PQ, so we're coming straight down, trying to find that distance. Notice that even though I was not in a right triangle to begin with, I now am inside of a right triangle, and I'm trying to find H. I want to know what the perpendicular distance is from the top down to this segment called PQ. So if I'm looking at this properly, I see that in this right triangle, let's see, how can I attack this? I could actually find, now you don't want to make the mistake of using the 121 for the bottom of the right triangle, because the 121 is from here all the way to here. It is not the bottom of the right triangle. It incorporates all of this little piece in here as well. So if I'm looking at things that have to do just with the right triangle, this 35.4857 does not have to do just with the right triangle. It's from here all the way to here. So I do have a 60. I want to find the H. Notice that I don't have any of the sides of this right triangle. I would love to use Sakatoa because that is, commonly used that when we're doing right triangles. Or you can use the formulas where you go sine is equal to y over r, cosine is equal to x over r. You can also use those. But I'm going to stick with the Sakatoa, and you need at least one side. We don't know the height. We don't know this piece, and we don't know this. Even though you may think 121 looks like the bottom, remember, we used it all the way back here, and it was the length from P all the way to the Q, from dead center all the way to Q. So we really don't have this either. So we're going to have to try and one more side in this big triangle where we were using law of sines. So let's go back to law of sines. We're actually not ready to use Sakatoa yet. And try to find this slanted side called the hypotenuse, which I have typically been calling R. So get your vision on the big triangle. If you look at, let's see, what other angles do we have here? So, we have the RPQ. That P right there, I'll just put an arrow. We do know that angle. We just found out that that is 84.5 degrees. And it happens to be across from R. So that's a complete pair. I would be putting the side on the top because I'm looking for it and taking the sine of 84.5 degrees. And I think I'm going to hold I'm going to hold 4 decimals after that. Let's see, that was actually 84.5143. I still have that in my calculator. 84.5143. Because I'm not at the end of the answer yet. If I was giving this as a final answer. Then I would use that rounded off version that I gave for the final answer there. But since this is going to help me get another answer, I want to be more accurate. So I'm using the 0.5143. Okay, we need one other fraction since we're doing law of sines. We used this angle and the side across from it. And we can also use, for this particular one, we could use 121. We could use this bottom. That's the entire bottom right here. And that 121 is across from the 35.4857. So we could use that. We could also go with the 60 and the 180.5. So that's up to you. Okay, I'm going to go with, and I'm going to use it with the angle that's across from it, which is this entire angle R. So sine of 35.4857. And therefore you want R to be isolated for. So you're going to swing sine of, let's put it right here, of 84.5143 right up here into the numerator. And then it won't be there anymore. And now put it all in your calculator. Let's see if I can get this closer. Okay, so R is approximately okay, 121 times sine of 84.5143. Close that top. And then the divisor divided by sine of 35.4857. Close that up. And we get 207. Still going to hold 4 decimals. 4864. Okay, now I can finally go and find this perpendicular height that they asked me for as my second answer. This problem purposely meant to be a multi-step problem so that you're switching back and forth between simple subtraction when you're just looking for the third angle inside of a triangle. You're using law of sines, and then finally at the end you have enough information to move into the right triangle, which requires that you know at least one side. I now have that one side right here, and so I can finally find the height because I can stand right here and I can go, let's see, this would be called opposite, and that would be called hypotenuse. So I can use sine again as I did in the previous problem. I can go sine of 60 is equal to the height over the hypotenuse. So that's going to be my fourth and final step. Okay, this was step 3. This is step 4. Okay, so I'm going to go 60 is equal to opposite over hypotenuse from socket to opposite would be the h, and then the hypotenuse would be this 207.4864. Okay, we're going to get this in the calculator. Let me write this down here because I'm running out of room here. Minus 60. Let me just give myself some more room. 207.4864. Now you can see everything. Okay, so the h is what I'm trying to isolate for ultimately. I'm going to swing that 207.4864 right up here. So it now becomes a multiplier in the numerator and is no longer down here, so that the h is by itself, and all you need to do is put that right in your calculator. So I already have the 207 times sine of 60, and I get 179, and they've said that for this answer we can round it to 2 decimal places. So I can go 179.69. 179.69. Again, you have all these answers on the last page. Let's just check those out. They only asked us for 2 answers in that problem, and we got 84.5 and 107.69. That's what I got. Yep, 84.517. Well, they got 1767. So yeah, I think they'll give you leniency to that extent. 67, I had 69. Let me make sure that both of them were 179. Yes, so approximately 179.69. Okay, then let's see. An awning that covers a sliding glass door. This is the last one, problem number 14. An awning that covers a sliding glass door that is 88 inches tall forms an angle of 50 degrees with the wall. Here is the awning right here, and it forms an angle of 50 degrees with this wall that's straight up and down. The purpose of the awning is to prevent sunlight from entering the house when the angle of elevation of the sun, so in order to see the sun, a person that's standing here would have to elevate their eyesight a certain number of degrees, is more than 70 degrees. So in that problem, this awning will only work when the angle of elevation is 70 or more degrees. So you're going to put a 70 right here for the angle of elevation, and then you're going to continue the problem. Let's make sure we know what the question is. They want the length L. So we're looking for L right here. We only know that the angle of elevation, the awning only works when the angle of elevation is 70 degrees or more. So we start there with a 70. But then from here to here, this is a perpendicular. It comes straight down to the horizontal. So that means from here to here is 90. But you already know 70 degrees of that 90. This is a whole angle right here, which happens to be a right angle, and you already know a portion of it. Therefore, this has to be 20 degrees. Okay, then when you go and look inside this triangle right here, notice that this is not a right triangle. So you can't use any of that SOHCAHTOA stuff. But instead, you may be able to use law of sines. Notice you have a 50, you have a 20, and this is like 100 and something, 110 degrees. That's right there. So for this problem, I think the very first thing that I would do, step one, is I would find that missing angle, because that missing angle is across from a side. Therefore, that would be a complete pair if you want to use law of sines. When you use law of sines, because we are going to have to do that. Ultimately, we want the length of the awning. So that is an incomplete pair, a partial pair, if you will. You want to find this. It's across from 20. So this is a partial pair where you know one but not the other. But this is a complete pair if you just subtract. So just go 180 minus the 20 and the 50 that are already there. You can subtract it all as one angle or separately if you want. Comes out to be 110 degrees. That goes right there. And now we can go on with law of sines. We can go that the L that we're looking for, this length, is across from 20. And remember, we're always taking the signs of the angles when using law of sines. Now we need one more fraction made up of an angle and a side that's across from each other. And that would be the 110. The 88 represents the side. And the 110 is what we would be taking the sine in. So this one is only 2 steps. Okay, all we have to do is cross multiply sine of 20 right up alongside the 88. And then we have the L by itself, and we're ready to put everything in the calculator. So that's 88 times sine of 20 divided by sine of 110 degrees. Close that up, and the answer is, let's see, we're going to round to 1 decimal place, so 32.0. And you can put, this is in inches, you can put inches in there, but they usually put the units in for you. On the test, you have to put in, well, you're going to be taking this test actually, well, it depends. Depends what type of class you're taking. If you're taking it in my math lab, they put the units for you, and if you're taking it in a face-to-face class, then you have to put the units yourself. Okay, that completes section 8.2. In the next video, we're going to be doing 8.3 and 8.4 combined, which is all there is in chapter 8.